Hello everybody, Root Beer here, looking at question number 6 on the 2007 Euclid Math Contest. Question 6, like question 5 before it and question 7 after it, has both a light bulb and a written part. So we can just fill in the light bulb question if we want to. Hopefully you've taken a look at question number 6. I'm about to do that now. So 6A, this is the light bulb, this is the we just need a short answer question. And it's always a good idea, even if you struggle with proofs, even if you have trouble writing things up, even if you think the written part questions can get really hard really fast, it's always a good idea to still try the light bulb questions. They do drop off after a while. But, if you want to just, do the first 4 questions in full detail and do the remaining light bulbs, that's not a bad score, especially for a first or second timer. Okay, but let's get into it. 6A, The Little Prince, which is an excellent book, lives on a spherical planet which has a radius of 24 kilometers and center O. He hovers in a helicopter, I don't remember that happening, at a height of 2 kilometers above the planet. From his position in the helicopter, what is the distance in kilometers to the furthest point on the surface of the planet that he can see? Okay, so let's draw. It's a fairly simple picture, so let's just draw this down. We'll need a new page here. Oops. We'll definitely need a new page. Apparently in the last question I'd gone back to talk about something. Let's draw a slightly bigger circle than that. Alright, that's good enough, I guess. So here's his helicopter. It's up here, point H. So let's ask ourselves, what can he see? Well, he can sort of see off infinitely into space in lots of directions. But in terms of the planet, what can he see? Well, he can see, right below him. And we can keep drawing lines. Now, notice that every line of sight that hits the planet can go through the planet and come out the other side. Maybe he's a Superman as well. So he can sort of see through. And so we draw all these lines. Now, because there's a little extra space over here, he can just shift his gaze a little bit, and our line's still going to cut through. And it's going to keep doing that until he looks and his line of sight just touches the planet. There's no further place to the right for him to shift his gaze. At that point, he's now looking off the planet, off into the distance. And we're only interested in places on the surface that he can see. So, his gaze from H to the planet is just going to touch the planet once and move off. Okay? And this is called a tangent. Okay? It's a line which just touches the circle at one point. So, if I were writing this up a little bit, I would say something like the furthest he can see is to the points of, let's say tangent C. Or I could say something like, his line of sight from H to the planet will be tangent to the planet. There's lots of things we can say. But it's important that we understand what this line is, because once we've got that, I'll just draw a less colorful picture, we can start to do some math. Okay, this turns into a nice little circle geometry question. So we got our 2 points here, and they are tangent points. Okay? They're tangent points, and it was, the Little Prince was in a helicopter 2 kilometers above and 24 kilometers out. So, what we can do is, I've got my center O, and whenever I see points of tangency, and this is probably a policy that you might want to adopt, anytime I'm looking at a picture of a circle and there's the tangent line, always, always, always connect the center up to the point of tangency. Draw that radius from the center to the point where the tangent line meets the circle. You will never regret doing this. I mean, it's just a quick drawing, and, if it doesn't yield results later on, okay, but it almost always does. So we're going to want to draw from O to these 2 points of tangency. And really, we only need one, but We'll do both of them. And points at tangent C and the radii connecting them to the centers have a nice property in that we get right angles. So we got 24 here, 24 here, because that's the radius. And then how far is H away from O? Well, it's 2 and 24. It's going to be a total of 26. And what have we got here? We'll highlight it in orange. We have a right-angled triangle. 24, 26, and then whatever this length here is. And that's the distance. That's as far as the prince can see when looking at the planet. So we want to figure out this distance. So I'll write the triangle off on its side. H to O to maybe call it T for our tangent point. We have 24. We have... there we go. Had it in the wrong order. T is at where the angle is. O is up here. We have 26. And you may recognize this as a Pythagorean triangle with a Pythagorean triple, and we get 10 over here. If you don't, that's okay. Just use the Pythagorean Theorem. HT squared is going to be the hypotenuse squared minus the other side squared. 26 squared, which is 676, and 24 squared, which is 576. Difference of 100. So HT is square root of 100. It is 10. So the distance in kilometers that the little prince can see is 10 kilometers. And we would put that in the box that they provide in the booklet, or we'd make a little statement that's very clear, maybe boxed off on its own, saying the little prince can see 10 kilometers when he's looking at the planet. That's the furthest he can see. Okay? But that's just A part. We still have a B part left to do. What have we got? In the diagram, points A and B are located on islands in a river full of rabid aquatic goats. Okay, they probably got into the alcohol when they were starting to make this question. Nah, there's some silly people making questions, and I love little things like this. I tease. Rabid aquatic goats. That's cute. Alright, so full of rabid aquatic goats, fine. Determine the distance from A to B to the nearest meter. So what do we want? We want A to B right there. Luckily, someone has measured the angles as shown in the diagram, as well as the distances CD and DE. Very nice of them, and probably quite risky considering all the rabid aquatic goats. In all seriousness, they don't drink when they make up these questions. I'm just kidding. Alright, so lots of angles in degrees as well. What are we to do? Well, I mean, this is basically half the question here is, what is our plan of attack? Once we have, we do this, we check to see if this is parallel, we find this length, that sort of thing. Once we have a plan of attack, it's actually quite quick to start executing it and writing it up. And if you think about it, if you have a strategy for doing the question ahead of time, that also guides you as you're writing it up. Okay? The alternative is just sort of word vomiting on the page of, I make this observation. Okay, over here I make this observation. Here, this observation. And then eventually you start to realize, oh, we can do this. Oh, okay, it works like this. Now that doesn't make for the nicest thing to read. It doesn't have, very nice flow or structure. And sometimes you can confuse a marker and lose marks if they don't understand what you're doing. So, for questions like 5, 6, 7, even 8, a plan of attack is very nice to have. It'd be nice to have for 9 and 10 and the earlier questions as well. I find with 9 and 10, I only have so much time, and I'm trying to grapple with a brand new concept that they're throwing at me usually. So I tend to word vomit on the page. Better mathematicians than me, they can see the plan of attack right away. But it's a good idea to have a plan of attack. It aids in writing things up, not just in solving the question. So, I want a B. Well, let's focus on this triangle in here. I've got a 35 degrees. How can I figure out AB from just this 35 degrees? Well, if I had the angle at A or the angle at B, I might be able to use some sort of sine law. But I think, just because we have the angle opposite, I think a cosine law would work. And so I need AD and BD. So I'm sort of working backwards. I will be able to answer AB when I know AD and BD. Okay, new question. How do I get AD and BD? These are two separate, smaller questions. But now I notice, AD, in this triangle up here, I have the angle opposite. And I have a length here. And I can probably figure out this angle right here. So I could use the sine law. Similar sort of situation down here. So once I realize that, once I start reducing, working backwards to simpler problems until I finally just have the information that I was given in the problem, now I can start writing things up. So let's draw our picture. I mean, we don't really need to include the islands, but I choose to. So there's C and E and D. Oops, E's down here. Here's C. Just because we have the picture in black, I'm going to use colors. Alright, so we will solve for the red dotted length. And we will solve for the blue dotted length. And once we have done that, we'll be able to combine these. With our powers combined, we will get the green dotted length. That's sort of my plan of attack. I'm not going to color code when I'm writing things, but that's just in my head. So 50 degrees, 150 meters. This was 45. This was 35. I think this was 20, or maybe it was 25. No, it was 20. And we get a 70 up here. And 100. Okay. So I might say something like ACD and BDE are triangles. So the angles add up to 180 degrees. And so I might say, I'm probably not going to show the calculation. It's question 6. We start to write less of the basic calculations, because now we're getting more marks for our reasoning, not our calculation skills. So 20 and 70, that makes 90. So this is going to be a 90 in here. So angle DBE is 90. And we've got 45 and 50, that's 95. So what's left over here? 85. So I might say something like angle CAD is 85 degrees. Okay. What can we do now? So now that I have those angles, I might say something like, using the sine law. This question seems to very much be trigonometry, at least the way I've constructed it. Cosine law to get AB, sine law to get AD and BD. So using the sine law, we have AD over sine 50 is equal to 150 meters over sine 85 degrees. Okay, and they said something about to the nearest meter. So that's pretty important. Not only does that tell me that I'm going to need my calculator at some point, and I certainly do need a calculator if it's trig-based, because I can't really do by hand something like sine 50. I don't even know how I would guess at that. Well, 50 is between 45 and 60, so I would probably try and just guess a random value between sine 45 and sine 60. Anyway, it wouldn't be a good way to go about this question, so calculator is sort of a must at this point. But they're also telling me to the nearest meter, so something I need to keep in mind is I don't want to solve any equations, I don't want to calculate any values until the last possible second if I can. Okay? It's usually nothing, especially on Waterloo papers because they're well put together. But you get some of these other contests around the world and people just have put together an interesting question without testing it a whole lot. You can get rounding errors. If I start calculating AD and I just round to the nearest meter, and then I calculate BD and I round to the nearest meter, that's rounding things off too early. Then when I use cosine law, I'll get AB and I might be off by a meter or two, and that will absolutely mess up my answer. So I don't want to solve for things until I absolutely have to. Okay? And that can mean that my handwritten calculations get messy, as you're going to see. But it saves me from those rounding errors. That 1 in a million time that rounding early is going to get you, you want to avoid that. Okay? We want the best possible marks that we can have, and sometimes that means a little more handwriting is required. So I'm going to rearrange this and say AD is 150 over sine 85 times sine 50. Okay, and I'm not going to figure out what that is. If I wanted to, if I was worried, if I was running out of time, I might off on the side write out approximately what this is, but I would not use that in my final calculation. Also with the sine law, we have BD over, what's opposite BD? 70. So over sine 70 is 100 meters over sine 90. Because that's what's opposite the 100. Now, sine 90, I do know that that's 1. So I can simplify and say BD is not 100 sine 70 over sine 90. I can just say it's 100 sine 70. Now, maybe things will cancel later on, and I'll wish I'd kept that sine 90, and I can always add it back in. And again, if you wanted to, if you were worried about losing marks, that you're going the wrong way, write out the approximation on from your calculator. But do not use that for your final calculation. All right, so I've got AD and I've got BD, weird expressions though they may be. Now I can use the cosine law to get AB. Using the cosine law, AB, the angle that we want squared, is AD, an angle that, or sorry, not an angle, I said angle both times. AB, the length that we want, squared, plus AD, a length that we know, squared, plus BD, a length that we know, squared, minus 2AD BD, and then the cosine of the angle in between them, which we are told is 35 degrees. All right, so AB is equal to the square root of, here we go, 150 sine 50 over sine 85 squared plus 100 sine 70 squared minus 2, 150 times 100 is 15,000, sine 50 sine 70 all over sine 85 cos 35. Okay, that's the key expression. We've got it. We have expressed AB in an exact form. Now it just remains for us to grab our calculator and actually say, what is this to the nearest meter? And that's going to be kind of boring, but here we go. 150. You can watch me do it. Instead of just listening to me do it. 150 times sine 50. Okay. 114.9, that's fine. Divided by 80, sine 85. Alright, so 115.34559, something like that. So I'll square that. Plus 100 squared is 10,000 times sine 70 squared. Alright, we're getting an answer so far of 22,134.8 something. So now minus 2 times 15,000 times sine 50 times sine 70 times cosine 35 divided by sine 85 And that should do it. Equals 4,377.34. And now I just want to square root my answer. $66.161 is what I'm getting, so that's what I'm going to do. Now, that was a lot of button presses. I would probably recommend you double check that. And here's what I'm going to do. I'm just going to very quickly double check it by calculating AD approximately. So 150 times sine 50 divided by sine 85. So he's about 115. Fine. 100 times sine 70. He's about 94. Okay. So 115. So these are a lot easier to work with. 115 squared plus 94 squared. Just to see if I roughly get 66.16. Otherwise, I should probably take a closer look at something. Minus 2 times 115 times 94 times cosine of 35. Another thing, it's also important to make sure your calculator is in degree mode. And yeah, that got me about 65.9. So yeah. So AB is about 66.16. They want to the nearest meter. So to the nearest meter, AB is 66 meters. All right. So that does it for question 6. Let's flip the page in anticipation of our next question, question 7, which, if I recall from just looking at it a little when I was scrolling through, it is the last one with a light bulb. That's it. And then we'll just be on to the last 3 questions, the hardest 3 questions, the written questions. But coming up next is question number 7. Thank you guys for watching. Feel free to like or subscribe to be kept up to date, or leave a comment if you had a different way of doing this. I mean, I used trig. You might use trig, but in a slightly different way. I would love to hear about it. I'm always eager to learn different strategies for questions, as I hope you guys are. But other than that, I will see you for question number 7 in the next video. Take care.